Welcome to Brain Vision.
In this video, we're going to be going over three concepts. We're going to be going over limits, working with the graphs of functions, and manipulating these functions. So, everything in here is built upon the responses from problem 77 and 79. So if you haven't already done those in your textbooks or watched the videos we have here on Numerate, I highly recommend you do, because I unfortunately don't have enough time here to explain those concepts again. So, we know from before that we are dealing with the function for the coefficient of thermal expansion. And what part A asks us to do is to use the info in the table to graph CT, and then to estimate Cmax and M. So, as per usual, I went ahead and I graphed the function for us. We know from before that the limit of C of t as t approaches infinity is Cmax. So, we know that if we're able to estimate the value of the limit of C of t as t approaches infinity, we're going to be able to approximate the value of Cmax. So if we look forward here, and let's extend the 24 line to see if it's close. We see that it's pretty close to 24, and because we're rounding to the nearest integer, we can get away with saying that the limit, or that Cmax, is equal to 24. So that's 1/2. The other half is m. And we know from before that C of m is Cmax divided by 2. And since we know what Cmax is, which is 24, we divide this by 2, we get 12, meaning that C of m is equal to 12. And what this means in relation to the graph is that when we input the value m, we get the value 12. So if we want to find the value of m, we can simply extend the 12 line to see where it intersects the graph, which is right here. And then we can extend this down to the bottom. And we can see, since we're rounding to the nearest multiple of 50, I believe, that this is about 1/50. So, in conclusion, Cmax is 24, and m is equal to 1/50. And that's part A. Part B wants us to use this information, our Cmax and our m, in order to create a new CTE function. So, let's do that here. We know from before that CT is equal to Cmax t over m plus t. So now if we sub in what we just found, we see that we have CT is equal to 24t divided by m plus 150. Sorry about that. 150 plus t. And that's part B. Part C wants us to use the function we just created here and to apply them to two scenarios. So the first is when the temperature is 600. And the second is when the CTE is 12. So let's do the temperature one first. So C of 600 is equal to 24 times 600 divided by 150 plus 600. If you evaluate this, you get 19.2 as your final answer. So if we know that our CTE is equal to 12, this means that 12 is equal to 24t over 150 plus t. So if we're going to evaluate this, we see that 12t plus 1800 is equal to 24t. Further evaluate this, we get that 12t is equal to 1800. And then as our final answer, we get t is equal to 150. So with these answers, we have completed problem 80.